Hello students, welcome to the first part of video lesson 631. We're going to sort of continue our trigonometry discussion in this video, and we're going to extend or apply the angle sum formulas that we looked at in our last video to derive or come up with what we call the double angle formulas for sine and cosine. Okay. Now, these formulas are helpful for us in terms of solving trigonometric equations and also helpful in terms of simplifying trig expressions, particularly when we go in the reverse order. Okay, but I want to show you first sort of where the double angle formulas come from. Then we will take notes on them. I'll summarize them. There is a math notes box of them for you on page 301 in your textbooks. But we'll sort of see through numbers 104 and 105 how the double angle formulas come about, and then we'll apply this idea to simplify trig expressions in number 106. So to start with, we will just start with this idea. The sine of 2 times any angle. Okay, so we have the sine of some angle here, right? Sine of A. And we want to go from sine of A to sine of twice as much as A. So, for example, this would be like going from the sine of 15 degrees to the sine of 30 degrees, right? We're just doubling the angle inside the sine function. And it does not just double the sine. Okay, so that's important to note. It does not double the sine. In fact, it certainly can't do that if we think about like the sine of, let's say, pi over 2. If I were to double that angle, pi over 2 times 2 is just pi, right? So this would become the sine of pi. It certainly does not double the sine value because sine of pi over 2, remember, is 1, but the sine of pi is actually 0. Right, so doubling the angle does not double the sine function's value, okay? But there is a formula for the double angle, sine of 2 times an angle, and it comes, as I mentioned, directly from the angle sum formula that we had in our last video. So what I'm going to do is I'm going to rewrite the sine of 2a as sort of an expansion of 2 angles added together, okay? So I'm going to rewrite the sine of 2a like this. The sine of angle, or angle A, plus angle A, right? Angle A plus angle A together makes 2 angle A's, but when I rewrite it in this form, this is now the sine of 2 angles added together. They just happen to be the same angle, right? So what I'm going to do then is use the angle sum formula on here, the sine of A plus A, right? So if we remember back, or we look back in our notes to the angle sum formula for sine, we do the sine of the first angle, right, times the cosine of the second angle, which happens to be the same thing, and then we add to that the cosine of the first angle times the sine of the second angle, which again happens to be the same thing. So now notice I have 2 different things added together here, but those 2 things are really the same thing, right? Sine times cosine and cosine times sine, it doesn't matter what order I multiply things in. And these are exactly the same thing. Sine of A times cosine of A, sine of A times cosine of A. So these are exactly the same thing, which I can then simplify to writing this. 2 times sine A times cosine A. Okay? 2 times sine A times cosine A. This right here is the double angle formula for sine. So the sine of 2a is really equal to 2 times the sine times the cosine. Okay, so the sine of twice as much as the angle is equal to 2 times the sine times the cosine, right? And now, as I mentioned, we can also certainly go this way, right? If I see 2 times the sine of something times the cosine of something, if the sine and cosine have the same thing inside the function, right, in these parentheses, then I can rewrite this as simply the sine, just original sine, of 2 times whatever the angle is in those, in the sine and cosine. You'll see an example of that a little bit later on, okay? But this is essentially number 104, okay? So this is number 104. Rewrite this like this, equal to this, using the double angle formula. Simplify it down because they're really 2 of the same thing, all right? So sine of 2a is 2 times the sine times the cosine. Now, if I do the same thing with the cosine, and I look at the cosine of 2 times some angle, this is going to get a little bit trickier. It's going to look a little bit less nice maybe, because we're going to end up with things that are squared and things like that, okay? But I'm going to start sort of my process. This is now number 105, by the way, and we're going to start by doing exactly what I did before with the sine. I'm going to rewrite the cosine of 2a as the cosine of a plus a again, okay? And then I'm going to use the double angle formula for cosine to rewrite this expression. Okay, so I'm going to rewrite the cosine of a plus a with my double angle formula for cosine. Now, if I remember back and I look back in my notes to the double angle formula for cosine, excuse me, not the double angle formula, the angle sum formula, okay? Angle sum formula, because I have 2 angles being added together, angle sum formula. Sorry, I misspoke there. If I look back in my notes at the angle sum formula for cosine, it says I should do the cosine of the angle times the cosine of the other angle minus the sine of that first angle times the sine of the second angle. Okay, so I end up with this. Cosine A times cosine A minus sine A times sine A. So what do we notice now about each of these pieces? They're really the same thing multiplied by itself, right? So I can simplify this then to say cosine squared A minus sine squared A. Okay, and this is the double angle formula for cosine. So cosine of 2a is really equal to the cosine squared minus the sine squared, okay? And of course, we can go backwards as well. Now, when we talk about cosine squared and sine squared, I hope that you guys sort of remember or are reminded of this idea, okay? So this is going to be kind of in its own little deal here, but we had a Pythagorean identity that said the sine squared of anything, right, anything, plus the cosine squared of anything is equal to 1. And of course, that works backwards as well. Cosine squared of anything plus the sine squared of anything, as long as, right, these x values, as long as the x's are the same in the cosine squared and sine squared, equal to 1. So I want you guys to notice the difference between the Pythagorean identities here and the double angle formula that we just came up with here, right? These were added together. Sine squared plus cosine squared is equal to 1. Cosine squared plus sine squared is equal to 1. When they are subtracted, they are not equal to 1. They're not equal to negative 1, okay? This is actually equal to cosine of twice as much as the angle, okay? Cosine of twice as much. Cosine squared minus sine squared is equal to cosine of 2a. Now, there are actually 2 other double angle formulas for cosine listed in your book in the math notes box. And they use these 2 ideas up here, or this Pythagorean identity, to write 2 different formulas here. And basically what they do is they take the idea that sine squared, if I were to just minus this cosine squared over to the other side, sine squared is equal to 1 minus the cosine squared, right? Sine squared is equal to 1 minus cosine squared. So instead of sine squared a right here, what you can do is you can replace that sine squared with 1 minus cosine squared. Okay, and sometimes it is nice to write things only in terms of cosine or possibly only in terms of sine, and that's what this allows us to do. Okay, we can remember our ideas from the Pythagorean identities. We can replace the sine squared in our double angle formula, And now it says this, cosine squared minus 1 minus cosine squared A. So if I simplify this down a little bit, the cosine squared A, when I minus both of these pieces, I'm really minusing the 1 and I'm minusing the minus cosine squared, right? So there is going to be a minus 1 certainly. There's also going to be a minus cosine squared. Minus or minus a negative is really like adding. So this becomes plus cosine squared A. And then I still have a cosine squared A in the front. Okay, and when I have cosine squared A plus another cosine squared A, so what it becomes is 2 cosine squared A minus 1. Okay, so this guy right here is another double angle formula for cosine. Okay, this guy right here. 2 cosine squared A minus 1 is a very good option, as is this one up here. Let's see if I can do that. Ooh, that was pretty good. Okay, I can do this. This is one of my formulas here. And then there's one more that we sort of, again, go back to the original double angle formula for cosine that we came up with. And we go back up here, and instead of solving this identity for sine squared, we solve it for cosine squared. So we minus the sine squared over to the other side, and we get this idea that cosine squared x is equal to 1 minus sine squared x. Okay, and if I use that idea and I replace the cosine squared A, what I end up with is the following. Okay, if I take this and instead of cosine squared, if I put 1 minus sine squared, right, which is what we just decided this was equal to up here, and then it says, so that was cosine squared, and then it says minus sine squared. Right, now in this particular example, these parentheses mean absolutely nothing. So I can go ahead and get rid of those. And 1 minus sine squared minus another sine squared is really 1 minus 2 sine squareds, right? If I minus a sine squared and then minus another one, I've really taken away 2 of them. So I end up with this expression here, 1 minus 2 sine squared A. So notice that this is sort of the backwards version of this one. 2 cosine squared minus 1, and then 1 minus 2 sine squared, right? And this is another perfectly good double angle formula for the cosine of 2A. So any of these 3 boxes, okay, any of these 3 boxes, this guy or this guy or this guy, they are all equal to cosine of 2A, all right? So when we did the double angle formula for sine, there wasn't really any other good way to write that formula. Here we have 3 different options that are all helpful in certain cases and may show up in certain cases. So it is important to have all 3 of these in our notes. Okay, so that's why in our math notes box, you'll notice it says this, right? It says, okay, so here's our one double angle formula for sine. There's just one of those. Sine of 2 times an angle, sine of 2A, is equal to 2 sine A times cosine A. And that again came from that angle sum formula. Cosine of 2A has 3 different options. Okay, it equals cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Okay, all of these are cosine 2A. Make sure that these end up in your notes somewhere, because as I mentioned, they're going to be helpful for us to solve complicated looking trigonometric equations eventually. All right. Now, the other thing I'm asking you to do is problem 106. If you turn there in your book, you'll notice these 6 parts. And really what they're asking you to do here is they want you to take these expressions, these trig expressions, and simplify them down to something more simple. Okay, something that would be easier to deal with in terms of solving an equation. So the first thing that I want you to always notice or look for is, does this expression look like any of the formulas that I've written down in the past 3 months, okay? Because one of these is actually a formula that we learned a long time ago, and then we brought it back in this video to, okay. So here's the deal. This one says 2 times the sine of this thing times the cosine of that same thing. 2 times the sine times the cosine. Does that sound familiar? It should, because that's the double angle formula for sine. So this is really equal to the sine of 2 times whatever this stuff in the parentheses is, okay? 2 times whatever's in the parentheses. Now, I don't need to write it 2 times 3x, right? Because we can do that. We know what 2 times 3x is. It's equal to 6x. So this is equal to the sine of 6x, because this is precisely the double angle formula for sine, okay? Now, if we look down here, this one says cosine squared of something minus sine squared of that same thing. Cosine squared minus sine squared. Does that equal 1? No, it does not. It equals cosine of 2 times the angle, right? Cosine of 2 times the angle. So cosine squared of this minus sine squared of this, that's the same as cosine of 2 times the angle, the stuff that's in the parentheses, 2 times, in this case, 40. Well, 2 times 40, that's 80. Okay, now I'm not actually asking, in the problem's not asking you to do the cosine of 80, but you certainly could, right? You could do the cosine of 80. But that's it simplified down to a more simple expression, okay? And then, if we just look at this one real quick, it says 1 minus 2 sine squared. 1 minus 2 sine squared. Well, 1 minus 2 sine squared sounds like one of my, I think, double angle formulas for cosine. 1 minus 2 sine squared. Yep, 1 minus 2 sine squared of whatever that is really cosine of twice as much as that. So in this particular case, I know this is equal to the cosine of twice as much as whatever's in these parentheses, right? So y minus 5, distribute. It's really the cosine of 2y minus 10. Okay, and I promise you, this is much easier to deal with in terms of solving equations than 1 minus 2 sine squared y minus 5. Cosine of 2y minus 10 is way easier to use, all right? Now, I'm going to let you guys finish up the other ones. This top right one, letter B, should be very easy if you've just been following along and paying attention to what we've been doing here. This one actually goes back to our previous section, uses maybe some other formulas, maybe like an angle sum formula. And then this one is a double angle formula again. So you can come up with your own answers for B, E, and F for 106, and then that will complete your work for this video. So if you have any questions at all about these double angle formulas, or how they're going to be applied, or what we need to be able to recognize, particularly in number 106, do please reach out to me, let me know so that I can help. In our next video, we will talk about half angle formulas, which are a whole nother ball of wax. Until then, if you have questions, reach out. Otherwise, that's all I have for you right now, and we will talk to you soon.